Hello, and welcome to Solving Quadratic Equations by the Square Root Property. This is an intermediate algebra approach. Although the square root property, really the only level difference will be probably in the examples. The property is just the property no matter what. So the square root property says, if c is greater than or equal to 0, all right, so 0 or positive, the solutions to the equation x squared equals c are x equals plus or minus the square root of c. If c is negative, then the equation has no real solutions. All right, no real solutions. So how can we use this? The steps to solving quadratic equations using the square root property are as follows. First step, isolate the squared part of the expression. All right, the squared variable part. Step 2, use the square root property to undo the square. Make sure to use the plus or minus on the side away from the variable. It'll just be easier that way for us. We're going to rewrite as two equations, one for the positive, one for the negative, and then we'll check the answers in the original and make sure that if we have word problems that they make sense in the context of the problem itself. So let's scroll up here a little bit and see what we can do. First step, isolate the squared part. So I will add 4 to both sides. Now I'm going to use the square root property. See, I have x squared equals a positive value 4. So now I know that my square root property tells me that the solutions will be x equals plus or minus the square root of 4. I use the plus or minus on the side away from the variable. I'm now going to rewrite as two equations and solve. Square root of 4 is 2, and the negative square root of 4 is negative 2. Let me see. 2 squared is 4. 4 minus 4 is 0. That one works. X equals negative 2. Negative 2 times negative 2, that's negative 2 squared, minus negative 2 times negative 2 is 4. 4 minus 4 is 0. Just a quick reminder that when you are doing x squared minus 4, let's do this instead. I'm going to do 2 store for x. So now anytime I type the x, it's going to tell me it's 2. So I'm going to do x squared minus 4, and I'll get 0. Notice that if I store negative 2 for x, and I pull up my x squared minus 4, it tells me it's also 0. Very big tendency of students to try to do negative 2 squared minus 4. Oh, it doesn't work out. But that's not what's happening. That whole negative 2 is being multiplied by itself. So anytime you substitute, think of that variable x opening up into parentheses. So it's something squared. So inside those parentheses, I replace it with the negative 2. So the negative 2 with no parentheses, checking your work, bad. Always good to check your work. But you got to make sure you check it correctly, or else you'll get incorrect results about your correct answer. All right. Yeah, that got me confused too. All right, so first step, isolate the squared part. Second step, if c is negative, negative 9, the equation has no real solutions. We will talk about that by the end of the semester, but for now, no real solutions. Let's try this again. So we want to isolate this squared part. I want to get that completely by itself. So let's subtract 12 from both sides first. Negative 3x squared equals a negative 27. Now keep in mind that this whole if x squared equals a negative value, there's no real solutions. That's after the square is isolated. Only after it's isolated. Here I see, oh, the whole thing equals negative 15. Don't give up on yourself yet. Don't give up on the problem. We have to do the work to isolate first. So here we see that x squared equals 9, which I'm going to rewrite up here so we can work with it a little bit better. As we're isolating the squared part, we see that, oh, the square is equal to a positive value. That's fantastic. That means the square root property tells us that x equals plus or minus the square root of 9. we turn this into two equations, x equals 9 or x equals negative square root of 9, which tells us x equals 3 or x equals negative 3. And we can check. 3 squared is 9. 9 times a negative 3 is negative 27. Negative 27 plus 12 is negative 15. And if we check negative 3, we would have the same result. All right, fantastic. We're going to do the same thing a few more times. Actually, 3 more times. Now, it doesn't matter if I'm isolating just x to b squared or an expression. So I can add 20 to both sides and isolate the squared part, p minus 5 all squared, and get 24. And that's a fantastic answer. Maybe not the answer we want, but it's the answer we have. So something squared is a positive value, which tells us that that something, the p minus 5, will be equal to plus or minus the square root of 24. Now I'm going to take a little interlude here. The square root of 24. Oh, let me see. 24 feels very much like 4 times 6. I use 4 times 6 and not 8 times 3 because I want a perfect square, because it's a square root. So I'm going to simplify my radical first, and now I'm going to lead into my two equations. I'll have p minus 5 equals 2 square root of 6, and p minus 5 equals negative 2 square root of 6. When I add 5 to both sides, I'll end up with 5 plus 2 square root of 6, and add 5 again, I'll have 5 minus 2 square root of 6. This whole idea of solutions being positive one thing and negative the other, kind of this form, we'll see that a lot. All right, we'll see that a lot, and I'll talk about why that is in a later video. All right, so now this one is not as horrible as some that might follow. So I encourage you to hit pause, try the method on your own here, and then unpause and come back and see if you got the same thing I did. I could wait for you to pause, but that's ridiculous because that's what the pause button's for. All right, so we want to isolate our squared part. I want this n minus 4 completely by itself. And we think about it as 1.5y minus 14 equals 82. So I approach this whole squared thing, that's just a variable. I just want to get it by itself. So the same ideas, I'm going to add 14. Same ideas, isolating the squared part as just solving for y. I'll have 1.5 times n minus 4 all squared equals 96. To get the n minus 4 by itself, I will divide 96 by 1.5. My calculator recently just turned itself off there. 64. Oh, isn't that nice? It's almost like this was planned. If n minus 4 all squared equals 64, then n minus 4 will equal plus or minus 64. And we break it into two equations. N minus 4 is the square root of 64, or n minus 4 is the negative square root of 64. The square root of 64 is 8. So if I have n minus 4 equals 8 and I add 4, I find that n equals 12. And if n minus 4 equals a negative 8, I'll end up with n equals a negative 4. And you should definitely check these answers. First of all, check them against the one that you solved after you paused. And second of all, check them in here. Check them in for n to see if it makes the equation true or not. All right, last example from this particular concept. Okay, so I'm going to add 20 to both sides. And I'll have, why would I add 20? Don't let me get away with that. I'm not an edit kind of girl. I'm kind of a This is what happens in a real human's brain. We all make these kind of mistakes. Right? I had already added 17 to both sides in my head to get that 20, and my hand didn't write the earlier steps. There we go. So let's add 17 to both sides so that we end up with 20 equals 5 times x plus 3 all squared. Now we'll divide both sides by 5. 4 equals x plus 3 all squared. Fantastic. We've isolated the squared. Doesn't matter which side the variable portion all squared is on, whether it's the left or the right. When I write it, I always write the whatever's being squared, right, in parentheses, equals plus or minus square root of the constant. So I always change the order regardless of which way it starts, or it kind of finishes, I guess, in this case. X plus 3 is plus or minus the square root of 4, so that tells me x plus 3, I forgot to hit shift there. Eraser, please, thank you. X plus 3 is the square root of 4, or x plus 3 is the negative square root of 4. We know, I did it again, that square root of 4 is 2. So now when we subtract 3 from both sides, and I'm going to write it down, seems as though I'm struggling a little bit right now. Anytime I find myself struggling, I promise, I know all this stuff. I've been teaching it for over 20 years, but sometimes my hand and my brain don't communicate very well. That's when I make sure I write things down so I know that my hand is doing what my brain's telling it to. X equals negative 5 or x equals negative 1. And you can see that 3 happens to be in the middle of 1 and 5, so it seems reasonable. Definitely seems reasonable. Also, 4, right? It's not necessarily, never mind. If this were a vertex, it would be a positive 4. 8 above that is 12. 8 below that is negative 4. If this were a vertex, it would be negative 3. 2 below that is negative 5. 2 above that is negative 1. So a lot of this goes with the vertex form that I talked about in an earlier video. All right, that's it for solving quadratics by the square root method. I'm going to call this part 1. Part 2 is, I'm not going to call this part 1 and part 2 at all. I changed my mind. I'm still not going to edit it out. That's it. Thanks for listening.